Right, that's all recorded now. She can sue you. Right, okay. Let's do it so. Right, okay, what are we to do? They didn't ask us to do it, but what do we know we have to do?
Find the intersection.
Well, we have to see if there's an intersection, because if they're mutually exclusive, there's no intersection. And then we have to see, does the independent formula that you all know already see fit, but before all that, what do I need to do? I need to draw a Venn diagram, okay?
So
right.
mutually exclusive if they're...
Can't happen at the same time, there's no intersection, they don't overlap. Right? Okay, so E, F. Okay? So we add, so we know 1, 2, 3, those 3 sections add up to 13 over 30, yeah? 1, 2, 3 sections add up to 13 over 30. Right, okay? So if we add the 2/5 that we know and 1/6, 2/5 and 1/6 on the calculator would be over 30, would be 12 and 5, 17 over 30, I think. So how many, that's how many too big? The whole lot, 1, 2, 3, can only add to 13 over 30. I think when you add them, if I did that right, 12 and 5, 17 over 30. So how much too much have I? 4 over 30. So that must be in the overlapping bit. Okay? So 4 over 30 must be in here. Okay? Is that alright? Does everyone see how I did that? Right, you add the 2 and see what's the extra bit. Okay? Yeah, please do check the calculator because, right, okay. So 2/5 take away 4/30. 4/30 is the next thing I have to do. Take away 4 over 30. So 2/5 is 12 over 30. Take away 4 over 30, which is 8 over 30. Which I know all these can be cancelled down, but I'm just leaving them because they're easier, add and subtract, if they're all in a common denominator. I think I'm right there, am I, girls? Yeah. And 8 and 4 makes 12, and I am allowed 13 over 30 in the whole lot, so that's 1 over 30 here. Is that okay? And there's 1 over 30, 4 over 30 and 1 over 30 makes 5 over 30, which is 1/6, so I know I'm right. Then what's on the outside? 8 and 4 makes 12 and 1 is 13. So there's 17 over 30 unaccounted for, so they must be on the outside. Is everyone okay with how I filled out that Venn diagram? Right, okay. So then, right. Question 1 is it mutually exclusive? Answer? No. So not ME, mutually exclusive, because there's an intersection. Because E intersection F is 4 over 30, which means they can happen at the same time. They have a 4 and 30 chance of happening at the same time, so it's possible. They can happen at the same time, so not mutually exclusive. Is that alright? Second bit, are they independent? So to check independence, you have to see is the probability of E intersection F equal to the probability of E multiplied by the probability of F. Okay, and that's, as I say, you have to remember that formula. Okay, so E intersection F is 4 over 30, right? Do I get the same answer when I multiply the probability of E is 12 over 30 multiplied by the probability of F, which is 5 over 30. That's does 4 over 30, will someone do that? It'll probably go 2/15, will it? I'd say they are. That's 60, yeah, 62, yeah. What is it? 1 over 50?
15 for 2/30.
Alright, so 1 over 50, and so are they independent? No, because that's not the same. 4 over 30, not independent. I for independent. Right? Not independent. Because that didn't hold true. Is that right? Okay. Do you want to look at one of those before we move on to the last section? So, yeah, sorry, I'll rephrase that. we will look at, ye will look at one of those, ye will look at one of those, right, okay, so let's do, let's do page 214. How do I get 4/30ths for intersection in there?
Yes.
Right, so when you add up 2/5 and 1/6, when you add 2/5 and 1/6, you get 17/30, right? But it says in these three sections you can only have 13/30. So I have 4/30 too much, so that must be in the overlapping bit. Is that alright? Okay. So will we do, so page 214, let's do number 5, right? So page 214, number 5, right? And if that goes well, we'll move on. And if it doesn't go well, we'll do another one. So page 214, number 5. So we've A, we've union, so the first bit, right, they are two independent events. So that means you know that this formula holds true. That probability of A intersection B equals the probability of A multiplied by the probability of B. Because they're telling me they're independent. Okay? So you know that holds true. So you'll be able to find stuff from that, will you? Will you? No? Okay. Might not. Probability of A, union. Use the formula that PA plus PB minus two independent events.
What? Hold on.
Union.
If A multiplied by B, right? And this is 1 PB, so 1 PB, oh minus, so we'll do something. No, I don't know, I probably did this completely wrong.
So
Like I'm kind of replacing substitution. Difference happening.
oh wait.
Minus this. 1.
Right, I picked the wrong one, I think. Right, anyway, come on, let's figure it out. A union B is 0.7. Right now, let's draw.
Wait, what did you get point? What?
This I need it over here.
So, A is 0.4. 1, 2, 3.
7 multiplied
Oh yeah,
by
look.
Yeah.
And then I stick that back in.
Probability of A is 0.4. Look, so these two bits here, look, this one and this one, add to 0.4, don't they? Right? But then it says A union B, so the 3 bits add to 0.7. So what do I definitely know is in here? If these 2 bits add to 0.4 and the 3 bits add to 0.7, this has to be 0.3. Would you agree? Okay? So, yeah?
Keep going.
Well, No, you don't get what I just did?
No, we get what you just said.
Right? Okay. I don't know, is that going to help us? Like, but yeah, that's
where we stop.
right. Probability of A by probability of B. I think we might have to use an X, will we? Will we call this X and call this 0.4 minus X? I don't know. Right? Okay. And then they said use this. So probably, they said use this 0.7 equals probability of A, which is 0.4, isn't it? Right, plus the probability of B, which is X plus 0.3, minus the probability of A intersection B, so which is minus X. That's great. 0.7 equals 0.7. That's really helpful. Right, okay. Right, let's go again. Right, let's try this. Intersection X is equal to 0.4 multiplied by X plus 0.3. I don't think this will work either, will it? So that's will that work? No. You get, so say if I do this, just ignore that, that was not helpful. Right, X is equal to 0.4X plus 0.12. So that's 0.6X equals 0.12. So what's X is equal to 0.12 divided by 0.6, which is 0.5. No, what is it?
That's the answer, but do it again.
Am I right when you divide 0.12 by 0.6 you get 0.5?
Yeah.
Yes? No, I don't. It's
Oh,
not.
yeah.
No, it's not.
No.
What's it?
Yes, 0.2.
It's 0.02?
But that's okay.
Yeah.
That is the answer, but the answer is,
Well, I'm not finished yet. Am I?
no, that's right. That's right. Yeah, that is right. It is
Yeah. So that's 0.2 in here.
right. Yeah, okay, so
Okay.
it is 0.2.
And that means that's 0.2 in here.
Yeah.
Right, okay. And that means on the outside it's 0.3. 0.2, yeah, 0.3. And what's the question? I forget. Right. Find probability of B 0.5. Right, will I start again?
Yeah.
Right, okay. So look, I'll rub the whole lot out and start again. Now, I don't know why they gave us that second formula because it didn't really help me at all. I used the first, they told me they were independent, right? So if they're independent, I know that the probability of A intersection B is equal to the probability of A multiplied by the probability of B. Okay? Okay, so then what did I do? I drew a Venn diagram. Okay? And I said, they told me the probability of A was 0.4. So I know this is A. So this bit here and this bit here add to 0.4. Yeah? And then they told me that the probability of A union B was 0.7, didn't they? 0.7. So that tells me if those two add to 0.4, this is definitely 0.3. Okay? Then I looked at their formula and didn't understand what they wanted me to do. So I decided I'd put an X in here. Right? So X in the intersection. The probability of A is 0.4 in total. So that means this bit here is 0.4 minus X. Okay? So then I filled out this formula. Okay? So probability of A intersection B is X equals the probability of A, which is 0.4 minus, sorry, it's 0.4. It's 0.4, it's the 2 bits. Multiplied by the probability of B, which is X plus 0.3. Okay, so that would be X is equal to 0.4X plus 0.12 bring the x's to one side, so that's 1x, take away 0.4x equals 0.12. So that means 0.6x equals 0.12. So when you divide that x, 0.12, so x is equal to 0.12 over 0.6. So that means x is equal to 0.2. Okay, so that means in there is 0.2. So the question was, what's the probability of B? So the probability of B is the middle, which I just figured out as 0.2 plus 0.3, which is equal to 0.5. Now, that's the way I did it. I'm interested to see why they gave us that stupid formula down at the bottom.
If you put in what you got after doing all that formula, you end up getting 0.5.
You end up getting 0.
So you have to, that they give you a formula.
Say that again?
Show the formula they gave you to get 0.5 for the answer. After doing all that, if you put like 0.2,
Yes.
0.4 and 0.2, and then x for b, you probably end up getting 0.5.
Yeah, probably. Minus probability of B. Yeah, when I filled in that formula with the x's and whatever, I ended up getting 0.7 equals 0.7,
Yeah.
which wasn't helpful. Right, to solve. I don't know, look, are we happy with that?
You should have another one.
You should have, yeah, that was the question. Yeah, if this didn't go well, we were going to have another one. Right, so will we go with number 7? Right, there's that formula for you in case you want it. Well, there's no in case you want it, you will want it. Yeah, then you get the intersection. Yeah.
Calculator. I feel like I'll get my calculator. Oh yeah, that makes sense actually. Yeah, that makes sense.
So it's that all over the thing. So it's
And then is there any back that goes to the outside?
Does that make sense?
Oh, I forgot. Hold on.
Because you're cancelling 0.7 divide.
0.6. 0.06.
So to get rid of
Okay, that wasn't too bad.
And then show they're independent. So then you have to say, you have to get the probability of A, do you?
They gave us the probability. Yeah.
They gave A and B.
Yeah,
Oh yeah. Yeah, so you just go probability of A intersection B. Does that equal to the probability of A multiplied by probability of B? And that does work out. That works out 0. What's that? 8 multiplied by 0.7. Okay? And that's true, and therefore they're independent. right? Okay? Yeah. I don't know why question 5 was way harder than question 7. Right, okay, that's really annoying. Right, okay. Will we do one more? Will we do 9? Probability, also we see on condition of D. What did I say, 9? We know they're independent, so therefore we know that this holds true. We know that probability of C intersection D is equal to the probability of C multiplied by the probability of D. Okay, so they say they are independent, so that means that formula works, right? Given that the events are independent, that's 2/3. That's equal to 2/3. Probability of C intersection D is 1/3, so 1/3 over the probability of
I'm not
D
doing it right. Come on.
equals 2/3.
Oh yeah.
Oh, you're gonna take the first?
Yeah. Wait, is this
so complicated?
This is D. Wait.
So intersection.
This would be D
Equals
then.
Yeah.
1/3 over 2/3. No, that doesn't work out.
Okay, so that was the second question.
Yeah. And then the
Yeah?
Two things on either side of equals, do you always have to cross multiply or can you just?
You can. Yeah, I cross multiply. Yeah, but I see what you mean with the fractions and stuff. I see. I'd put that over 1 and I'd cross multiply. Yeah. Equals a half. Probability of D. Did it work out to be a half?
Yeah.
Yeah. Okay. So then you know what's it? Probability of what are we looking for? Find the probability of C and probability of D. Sorry?
I mean, like, they asked to find C first, but we checked to find D before we could find C.
Yeah. It was kind of confusing.
Well, I found D.
Yeah, but like, they told you to act, like, they're saying find C first before you find D.
All right.
So,
Okay.
like, that's
Yeah. But all right. Okay.
doesn't matter.
A stupid book. Yes. Do we have the intersection? We do.
Yeah.
It's a third.
1/3.
So 1/3
Oh no.
equals probability of C multiplied by a half, and then divide each side by a half,
Or 2/3.
and you get the probability of C is equal to 1/6.
Yeah.
1/6?
I see they're independent.
Is that right or wrong?
1/3 is
I
equal
got
to.
1/2 for probability.
Oh, they're independent at the moment.
Probability of C.
Oh, thanks.
No worries.
2/3.
A half, right, 2/3, yeah, I just can't divide fractions in my head at 4:30 on a Monday evening.
Oh, never mind, that's probability of D.
Yeah, you worked out D. D worked out to be a half full. Yeah, I think that's, I don't think you can find C first, because C doesn't appear in this formula. Yeah. Right, okay. So they said the probability C in condition of D is 2/3, yeah? So probability of C intersection D equals 2/3 over probability of D. We know C intersection D. So it's 1/3 over the probability of D equals 2/3. Right, okay? Right, if you cross multiply, it'd be 2/3 times the probability of D. 2/3 times the probability of D would be equal to 1/3.
Yep.
If you cross multiply, and then divide each side by 2/3. So 1/3 divided by 2/3 is a half. Is that right?
Yeah.
So it's the fractions and the cross multiplying, it's just stick the fraction over 1 and it's just, yeah. You have calculators, you should be, yeah, better than me at this. Right, well, can I move on?
Yeah.
Right, okay. We'll be looking at more of these tomorrow anyway, like, because we're not going to, yeah, we'll look at more of these and the ones we're going to do now tomorrow. And then we'll, you can do your papers on Wednesday when I'm not here. And then on Thursday, you can ask me questions that came up in the papers that you didn't get, right? And then you're not here on Friday, isn't that right?
Yeah.
Okay, right, so that's the plan. I know it was a bad Wednesday to miss, but I didn't get to choose it, so. Right. Probability involving permutations and combinations, right, okay? So, there's nothing new here, right, okay? We've learnt about permutations, you know, how many different ways you can arrange stuff, and when the A has to be first and the E has to be last and all that kind of thing, right? How many numbers greater than 8,000 can you make out of these 5 numbers, you know, those kind of things. They were permutations. Combinations were selections, you know, select a committee from 11 people, select a committee that has 2 girls and 3 boys or whatever, right, okay, that was combinations, right, so we're going to combine our permutations and combinations from the start of the chapter with our probability, okay, so to find just some important stuff that might crop up, the easiest way, the only way to find the probability of an event occurring at least once, right, we use the probability that one takeaway it never occurs, right, okay, because, you know, it might be the probability of at least 1 boy is on the committee, and you might have to do, there might be 5 boys, so you'd have to do 1 boy or 2 boys or 3 boys or 4 boys or 5 boys, right, okay, as opposed to 1 takeaway, no boys, way shorter, okay, right, you still get the same answer, right, if you do it out the long way, still get the same marks, but it's just shorter, right, probability of at least 1 4, say, take away the probability of no 4, right, okay, probability of at least 2 heads, right, is the probability, 1 take away the probability of 1 head or no head, right, okay, because there might be 10 throws, you know, so it might be way longer, so, is that alright? Okay, we'll see him as we go along. Don't sweat it for a while. These are the hardest ones in the chapters, okay, I think anyway. But we'll go easy today and we'll step it up tomorrow, yeah? Right? Ready? Diane's on it.
Oh, yeah, you can go.
You sure? Because they're all talking. Right, there you go. Stop talking. And right. Right, okay, can I go? Okay, so first off, no probability for the first question. How many different ways can the team be chosen? How many people are you choosing from? 11. 6 and 5 make 11. Right, okay, I never thought I'd have to say that in a higher level class, but anyway, 11 choose 4. Right, okay. Will we turn that into a number? Right, okay. Will someone turn that into a number for me and call it out one number at a time? For 330. Right, so there's 330 ways you can choose a team of 4 from 11 people. Right, are we all happy with that? Now, the next bit is find the probability. Right, okay. So the team will consist of 2 men and 2 women. Right, okay. So we have to find how many of those 330 teams have 2 men and 2 women. So I want 2 men. So out of the 6 men, I'm choosing 2. And means I multiply. Out of the 5 women, I'm choosing 2 again. Right, okay. So into the calculators with that. That's 6 choose 2. That's 6 by 5. That's 15 multiplied by 10, 150, is it?
Mm-hmm.
Yeah.
Was I faster than the calculator?
Yeah.
Thank you. Right, okay, so the probability is, what's the probability? There's 150 out of a total of 330, which you cancel down if you like. Right, okay, number 2. Thanks. Thanks for hitting Diane. She's very nice. Joke. Right, 1 man and 3 women. Okay, so 6 choose 1. Right, and right, 5 choose 3 women. Okay, so yeah, I don't feel like showing off anymore. 60?
Yeah.
60?
Yeah.
Oh, I just got there ahead of you. I just don't want it low now, but I really was first there again.
How
60.
do you do the choosing thing, you're right.
What?
I said, how do you do the choosing thing, you're right.
I know. I do love doing maths in my head. It's how I go to sleep at night. I get the factors, I pick a random number and I start getting the factors of it. Yeah.
We should all research
I don't know how to do that.
60, am I right?
5 by 4 by 3. Yeah.
Yeah, see, you're divided by 6 here, so that cancels that 6, so it's just 5 by 4 by 3.
Yeah. Oh,
Yeah.
that makes sense.
Yeah. Right, okay. Yeah, are we good? Right, 60 over 330, you can cancel it down if you want. Right, okay, and part 3 is all women, so that means 6 men, bye-bye. Out of the 5 women, we want to choose 4. Right, okay, so that's just 5. So then it's 5 out of 330. Is that okay? So that's a nice easy one to start with. Okay? So you're using your combinations to work out the numbers and then just throwing them over each other to make a probability. Is that right? Okay. Example 2. In case we weren't. No, wrong button. Sorry. You may have noticed I love showing off being faster than the calculator. Love it. But sometimes my head won't work fast and I can't be faster than the calculator. Ready? No. Ready? Yeah? okay?
I think both.
Okay, this is it, girls. This is it. 30 more seconds and we're done, okay? Right, okay? So, the first one isn't a combination. Why isn't it a combination? Because you're only picking one disc at a time, aren't you? Right. Whereas if you look at part 2, they're picking 3 discs at a time. Right? They just put it in their hand and pulled out 3. Right? In the first one, it's not a combination, so it's just regular probability. Right? So a disc was picked at random and replaced. Very important. Right? A second disc was then picked at random, was then picked, find the probability, both discs showed prime. So I wrote them out. How many primes? 2, 3, 5, 7, 4 primes out of 3, 6, 9. 4 out of 9. Right? Okay. And so then you put it back. Right? So everything's back in place. And you want to pick a prime again. So 4 out of 9 again. Okay. So 16 out of 81. Is that okay? That's just regular probability, nothing new there. Right? Okay. So now we want to pick 3 discs at a time. Okay. So what's the probability that the 3 odd number discs or 3 even number discs were picked? Okay. So we have to say 3 discs at a time. So we have to say how many different ways can you pick 9, choose 3? Right? Okay. So 9, choose 3. Nah, can't.
84?
100, what?
84?
84? Oh, it's way off. Right, 84. Right, I'm hungry now and hangry and all that. Right, that's my excuse. 84. Right, what is the probability that the 3 odd numbers, so you want odd numbers, right, or 3 even number discs were picked? So what are your chances of picking a 3 odd number disc? So how many odd numbers are there? 1, 2, 3, 4. 4, choose 3. So odd would be 4, choose 3. Agreed? Am I right? Is there 4 odd numbers? 1, 3, 5, 7, 9. Yeah. Or means you add, isn't it? 3 even number discs. So how many even? 2, 4, 6, 8, 10. 5, choose 3.
We're not counting 10 down because it's 2 to 9.
Is it 2 to? No, it's 2 to 10.
Oh, it's 2 to 10?
Yeah.
Oh, sorry.
Right. That gets you nearly ruined everything, I hope. Right? Are we okay? Right, okay. So 4 choose 3 is 4. 5 choose 3 is whatever it is. What's 5 choose 3? What? The 2 of them add to 10 or it's just 10? 14 in total. Okay? So your answer is, what's the probability of choosing 3 odd or 3 even? Answer is 14 out of 84. Job done. Right? Okay? Harder ones of them tomorrow. And harder ones of the other ones tomorrow. Okay? Right? And don't forget your papers on Wednesday. Right? If that means throwing them into your bag tonight because you remember them tonight too. Right? Okay? You can throw them into the locker, okay?
Even if the test was on, no one study for it.
I know, I